back for a second. So these are the three basic methods that we're going to use to factor. And the first one is the sum of two cubes. It could be the difference of two cubes as well. But in order to do those two, you really need to know your cubes. So what is 1 cubed? 1. 2 cubed? 8. 3 cubed? 27. 4 cubed? 64. 5 cubed? 125. 6 cubed? 216. 7 cubed? 343. 8 cubed? 512. 9 cubed? 729. And 10 cubed is 1,000. Now, it's important to know these, but it's even more important to recognize that something is a perfect cube. So while you're working through these, if you say, oh, 512, gee, that looks like a perfect cube, you can probably work backwards and figure out what perfect cube it is. So first we're going to talk about the sum of two cubes. So some number cubed plus some other number cubed, or variable. The pattern is going to be, you're going to take the cube root of the first term, so the cube root of a cubed is a. You're going to take the cube root of the second term, so the cube root of b cubed is b. You're going to square a, then you're going to subtract a times b plus b squared. All right, and this is just proving that this actually does work. If I multiplied it all out, you can see that those two terms cancel, those two terms cancel. So in fact, I do end up with a cubed plus b cubed. But this is just proving that this, in fact, is how you factor a cubed plus b cubed. So let's take an example. X cubed plus 64. Well, the first term, a cubed, is a perfect cube, and 64 is a perfect cube. So this fits our pattern for the sum of two cubes. So I'm going to say a is x, and b is 4. I'm just taking the cube root of each. And now I'm just going to plug those numbers into our formula. X plus 4, so a plus b. The first term, or my a squared, well, x squared, minus a times b, so 4x. Plus b squared, 16. Notice that the only negative sign in here is this second one in the second parentheses. So go ahead and put this on pause and see if you can work through all of these and factor using that pattern. All right, let's see how you did. The first one, x plus 2. X squared minus 2x plus 4. A plus 3, a squared minus 3a plus 9. Now in this third one, your first term, you have to take the cube root of both. So your first term will be 2x. So 2x plus 1. And then when you square it, you have to have the whole thing squared. So it's parentheses 2x, close parentheses squared. So you have to square the 2 and the x. So 4x squared minus 2x plus 1. 3x plus y, 9x squared minus 3x plus y squared. 5 plus 2b, 25 minus 10b plus 4b squared. Now, if you prefer to flip this around and call number 5 8b cubed plus 125, you can see that it's going to come out the same way. It's just going to be in the reverse order. And number 6, 2x plus 5y, 4x squared minus 10xy plus 25y squared. Now let's talk about the difference of two cubes. So now we're going to say, well, what if I had a cubed minus b cubed? Well, the pattern is very, very similar, except now your first parentheses is negative and your second parentheses is all positives. So let's take a look at an example here. So the very first one, x cubed minus 27, well, I'm still going to take the cube root of the first term, which would be x, and I'm going to take the cube root of the second term, which is 27. I'm going to ignore the fact that there's a negative sign in between, because I've already taken that into consideration by using the a cubed minus b cubed pattern. So it'll be x minus 3, x squared plus 3x plus 9. Go ahead and put the video on pause and see if you can do the rest of these. Okay, how'd you do? A minus 4, a squared plus 4a plus 16, 3x minus 1, 9x squared, remember you have to square the 3, 9x squared plus 3x plus 1, 5x minus y, 25x squared plus 5x plus y squared, 2 minus b, 4 plus 2b plus b squared, and 2x minus 5y, 4x squared plus 10xy plus 25y squared.